we're going to start off today with our material right. I got some review we're going to do. We're going to jump into some basic information if we have time, but I definitely want to make sure we review some of the skills from our college algebra class that we're going to need in this course. Okay. One thing I will say, the laptops will become a distraction, as I believe I mentioned before. It's not something we need during class. So. I'm going to go ahead and start roll. We'll start right here in front of me. Start. Now the connections make sense. First and last names will be off. Grace and Groves. And Chris. Blaine. Blaine. John and Brooke. Is that John? Yes, I think John. For design. I'd say first name. Thank you, Brandy. Colin, you. Thank you, Colin. It is Brown. Thank you. Thank you, Colby. Thank you, Tom. Good day. Thank you, Cindy. Now, I am going to try to record this as y'all saw. That doesn't mean I get to skip class because I have recordings. Okay, that's just there. Or if something comes up, I'm using for all of those, right? Something happens. I try my best. Sometimes I forget to record those, so I will do my best to make sure to get them up. Oh, that's awesome. Some of you are finishing up. Does anybody recognize what that first expression is called? It's one thing I want to make sure that we have. If you haven't written it down or don't have it memorized, make sure this is something that you are familiar with. We won't necessarily use it all the time, but it is something that's good to know. It will come up in our course, especially when we get to equations. Okay, that one. I figure simplifying it though is definitely kind of our focus today. Make sure. I know not everyone's finished, but I do want to make sure we have time to go through and ask questions as we go. Okay. So let's focus on these expressions first. So when we're simplifying this, though, just make sure we're careful with that order of operations, right? Whether you use, please excuse my dear Aunt Sally, Pim this, Jim this, whatever it is you use, make sure you have that something you're comfortable with. It is going to come up with several things that we work on this semester. As I mentioned before, with trigonometry, we're going into some trig functions, right? We're going to be looking at functions that are different from what we use in college algebra. So we have a whole course focused on them. Order of operations will come into those when dealing with those functions, especially from just evaluating perspectives, graphing them, as well as some identities that we're going to work with. So make sure you're always watching that. So as we go through this first one, make sure you're comfortable with recognizing we deal with those exponents first, right? Now, the nice thing is if you're comfortable with it, you know you can do the multiplication at the same time because they're separate terms, okay? Was it 176? Is it 225? Getting to 15? Probably where 15 is coming from. Now, one thing we do want to be careful of, I walked around, I saw a couple people with decimal values, right? One thing I would look at that while we got that, oops, not erase it, sorry. What did we have here? It should be a plus, right? Because a negative times a negative. Plus, I didn't necessarily, I just saw decimals, I didn't see your work. But that would be one thing to watch out for. That's probably something that we try to change, right? So double check that. I did see a lot of people with 50, but like I said, a couple of people just double check your sign. That's probably all it was.
Okay. Was the rounding. If you don't round it, I think it's 14.866. That's probably the decimal word.
It should be an even 15 though, that's what I'm saying.
Oh, I ended on this like that.
No, you're good. Any concerns though with this first one? And like I said, the whole point of it though is to make sure, hey, I'm going to write down and make sure you don't have it memorized already. We're working on it. Make sure you have 2A on it though. I had to add. Okay. What's going on with the second one that we need to do to simplify? Okay. How do we expand it first? So remembering that an exponent means a number times itself, right? That is definitely the key here. The number times itself. With that said, what is, again, we got to go multiply this, right? There's different ways to do this. You know, distribution is ultimately what we're doing, but you might use FOIL to help you remember. Does anybody use the box method? That's a great method. But when we're going through here, I might use the box method in some instances because when we throw the trig functions in and we're doing some multiplication, it can get a little messy. Here, though, hopefully, whatever method you're comfortable with, make sure you're practicing to build some confidence with it, right? So like, hey, I'm just going to do the distribution here. 2 terms times 2 terms will give us 6 terms altogether. The one thing you always want to watch for, though, is to be able to combine like terms. Now, it won't always happen, but always watch for it. Okay. Any concerns with that one or questions? I know a common error I see here is just squaring the terms, right? Make sure you remember that, hey, that's a number times itself, and that's where we're going with when we expand it to the two factors, okay? What's going on with the last one that we have to deal with sometimes? We deal with some factoring, right? You got a fraction that's got all these variables going on, but the key here, we have something in the denominator would hint at factor, and that's going to be our exponent, right? Make sure you remember with exponents, that's going to be our hint that we need to work with factoring. So whenever we get down here and we say, hey, I got x squared, let's see if I can. Maybe I can, maybe I can't, right? This would be another thing that I would definitely want to tell you to always practice what you're comfortable with, right? One thing that I always make sure to show students is going through and using a little T-chart. It's not a perfect way because factoring doesn't always work, but it's just a great way to order what you're going on to. Some of you may have heard this called the AC method. Okay, and all it is just a helpful way to organize your work. Okay. But where does A and C come from? Where does this B value come from that I put there? So that's going to come from this expression. Okay. Whenever you see that, it goes back up to your kind of like how I wrote it. The A is the coefficient of whatever x squared is. The B is the coefficient of x, and the C is going to be your constant term. So the way that we'd write this out is like, hey, this is 1 times 15, and this is -8. Now, factoring, right, we say, hey, we want a pair of numbers that multiplies to the 15, but adds to the -8. Got to be the same two numbers, though. So what two numbers can we use here? 3 and 5, right? And they do need to both be negative, right? What we find here is I like to do this because the bottom chart, both sides are pretty much the same except for the operation. Now, if you're confident with this, do you need to write this out? No, right? I'm just making sure to kind of show something that is helpful for a lot of people. At that point, though, again, if you like to use the box method of factoring, if no one uses it for multiplying, you may not use it for factoring, though. All right. If you like to factor by grouping, or if you just write out the factors, each of those ways is great. What we find here, though, as mentioned, we factor so that we can simplify. And what about this allows us to simplify? What is it whenever you have a number over itself? Well, it goes to 1, right? That's the key. Hey, I can divide out. That's just 1. Now, be careful here, though, what's left over. We got to make sure we keep the fraction, right? Hey, 1 over x minus 3. Any questions, concerns with that one I can clear for somebody? Now, I will say that each of these, like I said, will come up at different points to course. Like when I think about this one, when we start talking about identities, right? If you remember logarithms, when I talk about identities, what's another way to write log of 2x? Okay. Well, I can break that down to log plus 2, sorry, log of 2 plus log of x, right? Those, when I say identities, we're going to have to deal with that in some ways. And simplifying things, right? Finding common factors like we did here is definitely going to be a part of that process, right? So keep in mind that's what we're going to use as we go through the course, okay? Any concerns, though, with any of the three here before we go to the equations? All right, so I started out with 2 equations. I had a couple more after this to look at. But I just want to kind of do some things as far as just building up our skills, because one thing that I want to make sure to reinforce is identifying what you're working with. That's definitely an important aspect of solving or simplifying. When you're trying to solve or simplify, you have to kind of identify what you're working with. So like the last problem we just did, hey, it's a fraction, let's factor and see what happens. What type of equation would you call the first one here when we look at this with the y variables? How would you name that? It's a linear, right? Why would you say it's linear, though?
I would say because of the
Okay.
I think because of how
It's good if we work it out, right? But some things to point out. Does it have an exponent? Does it have absolute value anywhere in there? Does it have a square root or other radical? Right? It's usually when we talk about that, it's the absence of a lot of those, right? All we have is the y with multiplication, addition, and subtraction, right? What I like to always do is start out like, hey, this is linear until you could identify something that would make it not linear, right? With that said, though, you said you worked it out, right? So what is someone doing here first? We got to simplify first, right? So make sure you remember as you deal with equations, always remember to simplify first, and then we can start solving. So in this case, you probably have what, 2y plus 6? And then we could write that as 2y, what, minus 1? From there, though, the ultimate focus of solving is to get what by itself? To get the y in this case, whatever variable we want to get by itself, right? We have to have different skills in place to do that. For linears, thankfully, we could just use the addition property or eliminating terms, right? By subtracting 2y from both sides, the one on the left is now 0. It's gone. I eliminated that term. While on the other side, I just do the subtraction and I have that y left over. Okay. We all in agreement though with getting negative 12? Any concerns with that one I can clear for somebody? How many of you took college algebra last semester? Most of you, okay, I think that'll help then, okay? Going on the next one here then, what changes how we approach this? It's quadratic, right? This is where we're doing with that square. Now, quadratic is a great name for it. Know that you could put it under an umbrella of polynomials as well. Okay, x cubed, x cubed, x to the fourth, all that. We're thinking what first? What should we try first? I heard multiple people talk, sorry. What were you saying? Up at the front here, I don't remember. Right, which is a very important thing. Anytime we're solving the polynomial, once we have exponent, right, we need to do that first, right? We have to get equal to 0 before we can do anything. So we're going to bring all this over here. And now we have something we can work with, okay? Once I do that though, right, the most straightforward path as we saw on the previous, the simplifying problem, is try to factor, right? The reason we like factoring is if I give you two numbers multiplied together, so a times b equal to 0, what must one of those numbers be? One of them has to be 0, right? Doesn't matter which one's 0, one of them has to be 0. Now the problem is, can I factor this? The 11 kind of limits us, right? With just 11 and 1 as factors. So what is our option if you can't factor? Quadratic form, that's one way to do it.
The constant that we have for the second one is 11 or 13.
This is 11. Did I change it? Ah, it's supposed to be minus 13. I didn't change it here. I'm sorry. It's not letting me do it. Minus 13 is what we had, right? Sorry. So bringing it all over to one side, though, make sure you see here. 13 is similar to 11, right? 13, again, all we have is 13 and 1, so we won't be able to get to 6, whether we add or subtract, okay? So I apologize about changing. Thank you for letting me know. Again, though, factoring won't work, so quadratic form is one option, okay? I would encourage you to practice that. Make sure you do it on your own. What I'm going to do right now is another method, okay? Does anybody remember where the quadratic form is derived from? What process? Okay, so this is the process that we use. Okay, I'm gonna get the 13 out of the way because I can't factor with it. All that leaves me with over here is z squared and z. Now the nice thing about this, what's the coefficient of z squared right now? 1, right? Nothing's in front of it, so it's 1, right? So that's the nice thing about it. The other nice thing about this, 6 is an even number. Okay. What we're saying is, hey, I can build two factors now. I could force this to factor. Completing the square is the call, right? And the reason we call completing the square is we don't want just any factors. We want to make sure it's two factors that are identical. Where did we just use that? Right here. If I can get two factors that are identical, I can write it as a square. That's why we call it completing the square. Now, all we have to work with is the 6. The nice thing about it is, what's half of 6? 3, right? So we can say that, hey, our two factors better look like this. We have to be careful though, because you need 3 terms to do that. Okay, so to get that, if you remember, this is where we'd say, hey, let's take half of b n squared. Okay. Now, the whole idea here again is to remember that we're trying to force it to factor to two identical factors, working with the value we're given. Now, if it would have been like 7 or something, an odd number, it wouldn't have been as nice to work with, and I could see why, hey, let's just jump to the quadratic formula. I want to make sure we practice this process just in case, again, like we said, when we deal with identities, something we might run into a situation where this helps us. Okay. When we're doing this, though, make sure you see here again, it gives me -3 squared, which will end up being 9. So that 9, we're going to say, hey, let's add it to both sides. With that in place, that'll give us the z minus 3 squared equal to what, -4? Now, we're still not done solving though, right? All we did was packaged it nicely. The reason we like this packaging is, how many variables do we see now? 1 variable, right? And this whole side now has the exponent, not just a single term. So what can I use to get rid of that square that's on that entire side? Square. That's the nice thing about this, right? We use complete squares so that we can go solve by using the square root. Now, when we do that, though, we have to be careful to remember the square root property. Okay. So when I go through this, what is the square root of -4? 2i, right? So it is 2, right? Remember, hey, square root of 4 is 2, but because it's negative, we need to put our imaginary. But how many solutions should we have? 2, right? And that's where the plus or minus comes from. Anytime you take the square root of a variable, okay? So since we had a variable here, we just put the plus or minus with it. All right, if you remember, that's the whole idea of the principal square root. Technically, we should have an absolute value, but we can skip some steps and just put plus or minus, okay? All that's left for us to do then is add the 3 to both sides. And we have our 2 solutions there, okay? Now, are we gonna run into complex numbers all the time? Not necessarily, okay? So keep that in mind. We're not necessarily gonna run into complex numbers all the time, but it's good, just a quick review just in case it does come up. The one thing I will say to you though is whenever you get a complex number, one thing to always remember is like, hey, this is not real. That's always one thing. It's no longer a real number. And if I need real numbers for something, like, hey, this is important, I made note of it, but I don't necessarily need it in the instance where I need real numbers, okay? Any questions or concerns I could further clear up here with completing the square for somebody? Now, do you have to do this process is my last question. We'll practice with this, right? That would be a good problem. Hey, let's go do this and make sure we get the same result when we're done, okay? Any concerns with either of these two? All right, so I got a couple more here for us. Before I forget, someone walked in after I took roll. Who was that? What was your first and last? All right, thank you, Dylan. Didn't I get yours though? What was it? Russell. Yeah, I got it. Anybody else walk in after I took roll? Now keep in mind, if I don't always remember, so if you ever come in late, just make sure you stop by me to make sure I do get it, okay? Now, these two problems I have up here, I want to give us a different perspective, okay? What is someone tempted to do with this one here that you saw for the first one? Or what did someone already start right? I saw a couple you going already. You moved it 10?
Yes. Simplify that.
So you simplified, okay?
Yes.
I see we're going, I would assume some of you probably simplified. Anybody already start writing this twice to multiply it out?
Yeah.
Perfectly fine like that. What do you notice about both groups of parentheses though? They're the same, right? Now, we don't run into this all the time. I made this just for a teaching point today. Like as we deal with solving equations, if you simplify this, you'll get a quadratic that could work like, hey, I can either factor it or I need a quadratic formula, okay? We know that because, hey, that's gonna give you y squared. I just wanted to show something different here. Okay, so I'd put this in your notes that like, hey, here's an example of substitution, because when we start dealing with trig function, sorry, substitution can sometimes clean things up for us to help us better see what's going on. Okay, with that said, I'm going to use the letter U in place of what's in the parentheses. Okay, substitution says, hey, I'm just going to use another arbitrary variable. It doesn't really matter what I use as long as it's not y. We're going to say U equals y minus 3. And the reason that this is helpful is because all of a sudden now, instead of that parenthesis, I can just put this as u squared plus 3u minus 10 equal to 0. And again, if you simplify this, you can get it down to a quadratic and get it dealt with the same. But this is just going to help clean up the process a little bit. That's all. It's not a requirement. How many of you have to take calculus? Couple of you. That'd be where you might run into situations where you are required to do. Okay, so keep that in mind. But for our class, it's more about cleaning up something to make it a little bit nicer to look at. Also, we took that and, hey, this is just a trinomial that I could try to factor again, right? So what are factors of 10 that subtract the 3? 5 and 2, right? If you need to, put the chart like I showed before. Use what's helpful for you. Are we okay though with where I'm getting a positive 5 and a negative 2 from? Now, since we hadn't done it, what do we do now once we factor it and it's equal to 0? We have two numbers being multiplied together that equals 0. We already said one of them has to be 0, right? So guess what? That's where we can just say, hey, doesn't matter which one. Oops, not A. One of these has to equal 0. Okay. Now, what do we have to be careful of here, though? We're trying to find y. We weren't trying to find u. Okay. So this is like, hey, if you like this process and we run into something that you're like, this would help clean it up for me. You have to remember down here, we got to go back. We got to go over here and say, this is actually y minus 3 equal to negative 5. So add the 3 to both sides gives me negative 2. And then y minus 3 equals 2, which adding the 3 to both sides gives me 5. Okay. Now, overall, this problem, you could have just simplified, would have been the same number of steps or amount of work in a sense, right? But like I said, it was just for a teaching point as we review some of this that could help. We're okay though with that substituting back in aspect there at the end? Any questions or concerns that I could clear up before we go to the next one? What's going on with the next one then that we got to be ready for? Cube root, other radicals. We did a square root a second ago, so we kind of should hopefully be on a good path there. I think it's a great one though, as we saw with the square root, it's just kind of remembering inverses in a sense, right? What helps me undo something, okay? But whenever we have the radical, what do we need to do first here? We could, but I would move 7 to the other side first, okay? Technically, you could cube both sides, but what happens is you have two terms right now, right? We want to get the radical by itself. That's going to make the cubing part as smooth as possible. So by moving that 7 first, all right, it leaves me now where all I have to do is cube the radical itself. And I can go forward. Now with the square roots in the square, right, we had to be careful of our solutions here, okay? The reason that is, all right, just throw something out there. What's the square root of 25, y'all? All right, what's the square root of 81? What's the square root of 64? All right, everyone in here instinctively just gave me one answer, right? Well, let's pick on 25. What's negative 5 times negative 5? It's 5, right? I mean, sorry, 25, right? Same thing as what we get when we do 5 times 5, okay? That's why we even mentioned the special stuff. Be careful over here, right? We didn't say the square root of 4 is negative 2, right? We put plus or minus 2 because of the variable. That's why we got two solutions here, okay? Do we have to worry about that with cubes? Right? What's 2 cubed? 8. What's negative 2 cubed? It's negative 8, right? So the sign gave me a whole nother result, right? So understand with cubes, hey, I don't even have to worry about it. That 27 is good to go. Subtract the 1 and I am done. Okay, so anytime you have an odd root, we don't have to worry about positives and negatives. It's the square roots of that that's going to be our concern. Okay. Any questions with that one? So any questions, concerns with any of the one things that we worked out here as far as simplifying or solving that helps them feel a little bit better about?
So for the one that we just went over, you said you just moved the 7. Where did it go to?
I added the 7 to both sides. So what we're doing is we're making that 0, right? And then when I add it here, that's where the 3 came from. Anything else? And make sure you ask questions, because like I said, once we get into this, the trig functions, and they're what we're dealing with them, we're going to deal with some equations, right? What you're going to find is we got to define some things first, like what is it that we're even working with? If you remember your college algebra class, how many of you knew what a logarithm was before you took that class? All right, not everybody. So that class was where you got to learn a whole new function and how it works, right? Well, that's what this class focuses on. Hey, what are some trig functions? How do we work with them? And we're going to end up building up to, like I said, identities, dealing with equations, and then some applications of them, right? So that's kind of the steps that we're going to be taking here. Now, like I said, the purpose of this, and there's so much more I could do. I put a couple assignments, if I remember right, up already where you have some review. But I want to make sure that we're comfortable with it. So as we go, though, if there's any questions, make sure you ask so we can go back and like, oh, hey, was this something I did with a trig or was this an algebra step? Okay, because that can get mixed together quite a bit in this course. My next thing, though, I want to go into is laying some foundation as far as definitions as we move forward. Okay, things you might have worked with before, but are going to be something we use quite a bit in this class. Okay. So I have 4 images on the left and then 4 names on the right. I want you to match the ones that go together. right, so starting with this first one here, which word would you match it up with? Fine, okay. What's different about the next one then? All right. And the big difference is what? Has endpoints, right? Does everyone see that? The endpoints are definitely important. It's kind of like if you remember the graph of a square root function, right? There was an endpoint that was very important in finding that when you go to graph it. Okay. What about the next one then? What do you think that is? Okay. Probably process elimination helps, right? I feel like some of these things you've worked with probably at some point, just kind of reminding us definitions, and we're definitely talking it's moving forward, like how we use it for this class. So here, this one then is going to be our angle. I will say this though, as we move forward, the angle is going to be the focus of this course, right? Dealing with angles in different situations, okay? Dealing with angles is definitely important. Things that I will point out is make sure you pay attention. Am I working with the line subjective or am I working with a ray? Okay, towards the end of the semester, we'll add another one to this list that we have to watch for, okay? Now, what we find is we're not going to just do angles by themselves. We want to put it into a situation where we have some order and consistency. So we're going to have an angle and we're going to call it like the standard position and such. So I have something drawn here. What would someone have called this when they see this little X here that I have written? All right, just coordinate plane, right? It's coordinate plane. Now, typically we use a coordinate plane. We have the horizontal line is what? X, and our vertical line is Y, right? And that's definitely one thing you do. All right, we'll find with this course, sometimes we can change it up depending on what we're trying to work with, okay? With that said, when I deal with this, we want to make sure we're familiar with stuff like this. So why am I putting these little Roman numerals here? Quadrants, right? Now, why did I put the one at the top right? What's special about that typically? Both the horizontal and the vertical line are positive, right? These are going to end up being just number lines, right? And that's where both of them are positive. Well, then quadrant 3 then must be what? Negative. Everyone go with that, both negative for quadrant 3. So that's definitely an important thing. Now, as far as dealing with angles, okay, we're going to take this little coordinate plane situation and we're going to set a definition in place, okay? That definition is going to be such. So if I want to draw an angle, I'm going to put this vertex right at the origin. The vertex is very important. That's where our two rays that you saw over here on this image, those were two rays joined together. The two rays have a shared endpoint at the origin. With that said, the initial side is going to be along the positive x-axis here. Okay, that's our initial side. That means whenever I go to measure an angle, I always start my measurement from this positive horizontal side, and then I go from there to get to the angle itself. The terminal side is what we're going to call it. The movement is from that horizontal to the terminal side. Those are definitely things that we want to have consistently in place because as we move forward, we're going to use this quite a bit in this form, okay? Now, there's different ways to measure angles. What's a common way that we use to describe how big or small an angle is? What measurement? I heard someone. Degrees, right? Degrees is one that we use. All right. Another one that we're going to talk about as we go in this class is also going to be radian. So that's going to be something we're going to work on. If we have time today, I'll do it. If not, it'll definitely be next week on Tuesday. But as I go through this, let's look at some common angles. that we can see. So just doing a quick sketch of some four angles here. I feel this is definitely something we've had definitions for that we need that. You probably heard before, but we want to make sure to refresh, okay? When we measure angles, right, there's two categories that are definitely important. I guess I should reorder these. That's focusing on this situation here, okay? Now, those two situations are dependent upon our understanding of this one here, though. Okay, what is special about this angle that I have highlighted right now? It's a right angle, okay? One way that we identify a right angle when we're using this, putting that little box there. What is the measure of a right angle in degrees? 90 degrees, okay? What is special about this one than that when compared to that?
Less than that.
It's less than 90 degrees, right? And it's, as you say, acute, right? I didn't draw it to measure right now, we're just making sure to show, hey, that's definitely less than 90 degrees, right? Which is going to be important because we deal with angles. That's one thing that we're always going to refer back to, okay? What angle are we working with? We'll even bring in this word reference angles because sometimes there's different ways to describe an angle for the given situation we're working on, okay? If that one's acute, then what would we call this one? Two is good. All right, now that goes back to comparing, hey, this is bigger than that 90-degree angle. Okay. Does anyone know what this one's called then? We'll call it a straight angle. What is the measure for a straight angle? 180 degrees, okay? Now, the only other one I haven't drawn then that's good to have a quick reference to, what if I just do the terminal and the initial side at the same place and go all the way around? What's that measure? 360 degrees, okay? Definitely can happen at times, right? You know that with angles, I could keep going if I wanted to, right? We could spin multiple times, right? So keep that in mind as we deal with that. One thing, sorry, one thing I want you to keep in mind though here is just get in the habit of where did I draw my initial side for all of these, right? Horizontally, going to the right. So positive x-axis, okay? Now, the reason we do that, again, it's just to have consistency in our work. We have a reference that we can always use to help us with working with something. Now, as mentioned, the next thing then is to go into this definition of the radian measurement, okay? Now, what I want you to take from here is as we deal with this, that's going to focus on two things, right? When I start talking about angles, right, it's going to bring in kind of this idea of a circle with it. We're going to see that circles and angles are going to start working together a lot, okay? When we talk about a circle, though, an important measurement with the circle is the radius, okay? With that, too, as we measure an angle, what is that part of the circle called, right? Make sure you see here, that would be something to highlight and say, that's just an R plane, right? What is the whole measurement of a circle called around the outside? Circumference, right? So make sure you remember the whole way around is circumference. What is the circumference equal? I heard a couple people I didn't actually hear though, sorry. No. 2 pi r. That's a great one. That's the one we're going to focus on because of radians, but some of you might remember pi times the diameter, right? Well, how many radii are in one diameter, right? Well, it takes 2 radii to make 1 diameter. So that's why these are equivalent. But this one's helpful, okay? This is going to give us a jumping point for dealing with what a radian is. Now, as we focus on arc length, make sure you keep in mind, that doesn't mean the whole circumference. Okay, so we're gonna have to build from there as we go. All right. But this is gonna give us a nice little bridge for that. Let's say that instead of one little segment, here we're going all the way around. So my angle is gonna be 360 degrees. Okay. Well, theta, which we're gonna use often for our angle, okay? And I will never draw it the same each time I do it, just so you know. If it equals S over R, right? Arc length over the radius. And I'm saying, hey, for this particular angle, I'm using 360 degrees. Then the circumference becomes our focus. Does everyone follow that? We're focusing on the circumference now rather than a portion of that. So that means then we can use 2 pi r all over r radians. Now what this does is going to give us a mathematical way to measure angles. Okay, this gives us a mathematical way of doing that, because what can we do with 2 pi r all over r? We can simplify the r, right? That just divides out. So this gives us 2 pi radians. So from a mathematics perspective, 2 pi, what is that equivalent to then with measurements? If we're talking about the angle, right, and I said, hey, we're going all the way around, it's 360 degrees. Okay, so 2 pi is equivalent to 360 degrees. Now, the thing that we have to make sure we see here, this is going to be our measurement in radians. And this is going to be our measurement in degrees. Okay. I feel this is a great quick way to refer to, like, hey, if I ever need radians, I just need to find the arc length of a circle. And you're going to find as we move forward, we're going to need to simplify this down to what we call a unit circle. Let's work with it when we force the radius to be 1. Make it a little bit easier to work with, okay? But the reason I like this is for setting up what we need. Well, I can go find other angles now just based on what I found, okay? We can simplify this down a little bit better because we have 2 pi and 360. Divide 2 off of both of them. Now we can say, hey, pi is equivalent to 180 degrees. So pi radians is equivalent to 180 degrees. So let's say we were working with an angle such as 120 degrees. And I wanted to convert that to radians. I can use that information to do so that we just had. Now, remember, this is just a unit conversion. So what we can do is just form some fractions, 120 degrees over 1 times what needs to go in the denominator. What are we starting with right now? What measurement? Degrees, right? So we want to make sure to put the degrees in the denominator. So this will be 180 degrees. And then the pi radians will go up top. Okay. Now keep in mind, we don't necessarily write out radians every time. So if you don't see the word radians, know that, hey, that's what we're converting to. The purpose of this is to get into radians rather than degrees. Pi is usually a pretty good hint that you're working with radians. Pi won't always be there though. With that said though, the reason we like this is because, hey, I could just say the degrees are getting dropped out because they divide out. And I just need to simplify 120 over 180. So what goes into 120 and into 180? 60, right? So give us what? 2 pi all over 3? Now, remember, I started with 120 degrees, right? So this is an angle, an obtuse angle. Roughly somewhere like that if I'm just drawing by hand, right? I could definitely go get like a protractor or something to help me draw that a little bit better. But with that in place, if this is 120 degrees, what we just found, we could also say that it is 2 pi over 3 radians. Right? Those two measurements are the same. Now, what you're gonna find here, the reason that this is nice, we call a mathematics measurement because we can use it within our equations a little bit better than we can 120 degrees. We could treat this more like a real number than we can 120 degrees, right? For 120 degrees to work, say in an equation, it needs to be built in a way that degrees are its input. Where with here, we could use this as a real number input, so we don't have to have as much restrictions in place when we're doing that, okay? So that's where we're coming from there. Any concerns though, as far as like where I'm getting the circumference from? Okay. Now, what I was trying to show you, this is the definition of a radian. You do your arc length divided by the radius, okay? So we bring a circle and that intersects with our angle, okay? Keep in mind, this is standard form. So the nice thing about that is this terminal line will be a radius. And as I rotate around, it's kind of like you're rotating the radius of the circle through. It's kind of what we can visualize there. The reason I like to do this here though is to make sure to show you that, hey, as I deal with this, this is going to be our what we use to describe an angle mathematically. So theta is usually reserved for angle measurements. We won't necessarily use X or Y. Theta is going to be what we use a lot in this course. Okay. There's other ones as well that can come up. But that gave us something we can use for conversion purposes. Now, remember, I had to force it though to a circumference. That was what I did here. If you recall, I said, hey, let's say we did the whole way around, not just part of the way. And now we have a way for unit conversion between degrees and radians. And you can do it the other way as well, okay? Any questions or concerns I can clear up there for you? All right, so that's where I feel is a good stopping point for us today. I don't want to go too much further. I believe I published, I had messed up, I can't remember if I messed up y'all's course or my online course. Has anybody been able to do an assignment on our course? Okay, so that means I need to fix this. I was trying to, somehow I converted something and did not go in correct. I might have to take stuff out and put it back in because you got messed up.
I saw that on our email, there was one that said it had been graded. I don't have access to this class and one of my other classes, Kansas courses. I need to talk to.
Yeah, make sure you
someone about
talk.
that. Yeah.
No, our class should be published. I've seen some of you uploaded your acknowledgement form, okay? Now, with that said, make sure you get that fixed. If you need help printing off your acknowledgement form, we do have a couple minutes left right now. Let's walk over to my office and get it printed off. Want to do that? All right. So if you need me to print off the syllabus acknowledgement form, you're going to need to follow me tomorrow. That's one of the reasons I'm making sure we had a couple minutes at the end here. There should be no reason that the acknowledgement form is not uploaded by 11 o'clock tomorrow. It needs to be printed off, filled out, and then uploaded as a PDF. So you have to scan it. Keep that in mind. But if you don't need that, have a good day, have a good weekend, and just keep before y'all leave. I may not see you till Thursday, if at all, next week, right? Y'all know why? Well, we don't have classes Monday, but there's some possible freezing going on Tuesday through Thursday. So please keep an eye on all alerts next week from the school, okay? Definitely keep an eye on those. I would go over to the BRCC help desk in the governor's building first. They might refer you to like Miss Lenora, but that's where I would start, okay?